Good afternoon, class. Pre-calculus practice test. Module 1 covering chapters 1 and 2. Here's chapter 2, linear functions, part 2. Extrema, maximum or minimum points on a curve. Extrema is the plural of extremum. So local or relative extreme value. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of A to B in the domain if f of C is less than or equal to f of x for all x values in the open interval. A local maximum is the maximum value within some open interval. Local maximum occurs at a point C in an open interval of A to B in the domain if f of C is larger than or equal to f of x for all x values in the open interval. So if you look at these two cases, local mean, local max, local mean, local max. Versus absolute, also known as global extreme values or extrema. So absolute or global extreme value or extrema are either maximum or minimum point on a curve. In other words, absolute minimum occurs at the point C if f of C is less than or equal to f of x for all x values in the domain, and that's the key. Absolute maximum occurs at the point C if f of C is larger than or equal to f of x for all x values in the domain. So if we look at these two cases, local mean, local max, local mean, but this one is also absolute mean. Local max, local mean, local max. This local max is also absolute max. Here's the reason. In this case, there is no other point having a smaller y coordinate. In this case, no other point in the entire domain having a larger y coordinate. That's why. So we want to understand and distinguish between the two. So here's the graph. Use the graph to estimate the interval where the function is increasing or decreasing. So this portion is increasing. This portion is increasing. This is decreasing. So let me just do the red one. This portion is decreasing, everybody, okay? So it's increasing from -8 to roughly -3. Union from 3 to 7. So a function f of x is increasing on an open interval I if for any choice of x sub 1 and x sub 2 in I, the interval. With x sub 1 less than x sub 2, we have f of x sub 1 less than f of x sub 2. In other words, x gets larger, y gets larger, increasing, increasing. On the other hand, a function f of x is decreasing on an open interval I if for any choice of x sub 1 and x sub 2 in I, with x sub 1 less than x sub 2, we have f of x sub 2, f of x sub 1 larger than f of x sub 2. In other words, x gets larger, y gets smaller. That's decreasing. X gets larger, y gets larger also, it's increasing. So the red portion is decreasing. So let me erase my work. A function is constant on an interval I if for all choices of x in I the value of f of x are equal. So having said that, increasing, this one corresponds to -8, this one to -3. So in that vicinity, and then from here 3 to 7 along the x-axis, you find the domain. Okay, so this portion belongs to this part. And now this one, the decreasing part in between these two numbers, -3 and 3, or parentheses -3 and 3. This is an inequality. This is interval notation. Determine any local maximum or minimum value. Well, this is a local maximum. That is equal to 50 and it occurs at x equals -3. The way we write it, local maximum equals 50 at x equals -3, or you may write it as a pair, however they ask you. What about the minimum? This is the local minimum. Peaks and valleys are local extrema. Okay, so this is the minimum. What is that equal to? -50. At one point, 3 comma -50. Now, determine any absolute max or minimum. The end points may be absolute max or mean, but they can't be local. So we have two endpoints. This one is the absolute max, and it's equal to 150 at x equals 7, or 7 comma 150. This is the way you write it. Absolute max equals 150 at x equals 7, or the pair 7 comma 150. Here's the absolute minimum, which has the y coordinate of roughly 225, and x is almost -8. So absolute minimum is -225 at x equals -8, or the precise location -8 comma -225. So this is reading the graph, understanding local versus absolute. For the following function, find f inverse. F of x is 2x minus 7. We want to find the inverse function. The very first step is to call this y, because it's easier to work with. Then we interchange x and y. This becomes x. This becomes y. And right here, we have the inverse. However, we do solve for y. That means I'm going to move the -7, make it +7, and then I'm going to divide by 2. That is the function I'm looking for. I'm going to call it f inverse. Now, you really have to check by looking at the composite function and making sure it's equal to x. So if we look at one of them is good enough. I'm going to do one and you do the other one. So if you want to go with f of f inverse, that means go to the f of x, this one, and replace the x with f inverse. So 2 times x is replaced with f inverse, which is x plus 7 over 2. These two cancel each other. X plus 7 minus 7. These two cancel each other, equals x, and it checks. Part B, the function is more interesting. It's a rational function. F of x equals x over x plus 2. We want to find the inverse. Therefore, we change f of x to y first and foremost. Then we interchange x and y. So this becomes x, this becomes y, this becomes y. And again, right here, we do have the inverse. However, we solve for y. To solve for y, we do the cross product. We multiply these two. We get x times y, x times 2. And over here, we get y. And since we want to solve for y, we are going to move this one, make it negative on the right side. We're going to factor the y out on the right side. We're going to divide by 1 minus x. That's the inverse. Give it the name f inverse of x equals 2x over 1 minus x. By the way we moved it here, if we moved it otherwise, we could get minus 2x over x minus 1. Please understand these two are identical. If you multiply the top by negative and the bottom by negative, that's what you get. Now, again, we're going to prove that using the fact that f of f inverse equals f inverse of f equals x. So we use one of them, f of f inverse. So we go to this function, replace the x with either this one or that one, makes no difference. We're dealing with a complex fraction. So you multiply the top and the bottom by LCD, and there's only one denominator, 1 minus x. So let's multiply the top and the bottom by it. When you multiply the top, you are left with 2x and 2x only. When you multiply these two, again, you're left with 2x only. And then plus 2 times 1 minus x. You distribute this one, you get positive 2 minus 2x. These two cancel each other. 2x over 2 equals x. So we proved this is f inverse of x. Use function composition to verify that f of x and g of x are inverse functions. F of x is cube root of x minus 1, g of x is x cubed plus 1. And to show that, you look at their composite function, either f of f inverse or f inverse of f. In this case, we're going to look at f of g, therefore, to see if we get x. So what is f of g? Replace this x with x cubed plus 1. And these two cancel each other. Cube root of x cubed is x, so that checks. You don't have to show g of f, but I'm going to show you quickly this one. Again, one of them is good enough. G of f of x means use the g function, replace the x with cube root of x minus 1. That's the meaning of it. If you raise this to the power of 3, it can undo the cube root, becomes x minus 1. Negative 1 and positive 1 cancel each other. It's x, and it checks. Sketch the inverse of the function whose graph is shown. This is given. So one thing that is important to note, throughout the line y equals x, you know that two functions that are inverse are symmetric with respect to the line y equals x and reflect the graph on the line. How do we do that? Pick up pairs. Pick up easy pairs, everybody. In short, when A comma B belongs to F, that means B comma A belongs to F inverse, right? So pick easy points. For example, you draw this y equals x. You look at this point. This point is an easy point with coordinates -2, -4. Belongs to f of x. That means f of -2 is 4. That means -2, 4 belongs, -2, -4 belongs to f of x. Then -4, -2 must belong to f inverse. So we write f inverse of -2 is -2, -4 is -2, and -4 comma -2 belongs to f inverse. So if you want, you can go from here to here. This, I want to explain the meaning of it. This means f of -2 is -4, and by the idea behind inverse function, if this is the case, then f inverse of -4 must be -2. But again, you can go right from here to here. So -4, -2 is this point. You plot that pair. Here's another one, another easy one. Obviously 0, 4. If 0, 4 is on f of x, then 4, 0 must be on f inverse. But to write that, we can write this means f of 0 is 4. And therefore, f inverse of 4 must be 0. And then 4, 0 belongs to f inverse of x. As I mentioned, you can just go directly to that. So we have this point. Now we have this point. We have one more point, right? Let's look at another point. Pick an easy point from the function f of x. you can read this as -1, 3. So if -1, 3 is on f of x, 3 comma -1 is on f inverse. Or if you write f of -1 is 3, which means f inverse of 3 is -1. But more importantly, from here, you can go to here and interchange those 3 comma -1. So you go 3 to the right, 1 down is this point. And if this is good enough, so be it. Okay. If not, pick up a couple more points, class. So basically, you graph it like that, you graph it like that, you bring it up looking like that. And of course, this point is in common for both of them. If the two functions ever intersect, it has to be on the line y equals x, because y equals x and x equals y, they can interchange each other, right? So if the function crosses the line y equals x, its inverse must go through that one also. So that's why it goes like that. And again, as I said, you can always use a few more points to be on the safe side as far as the graphing is concerned. Sketch the graph of f of x equals minus x plus 1 when x is between -1 and 1. -1 less than or equal to x less than x. It's equal to 2 at x equals 1 and x squared when x is larger than 1. This is what we call a piecewise defined function, everybody. So the way I'm going to graph it, I'm going to do it piece by piece without paying any attention to the restriction first. In other words, I'm going to graph this one, which is a line y equals -x plus 1. I can also, they still pick up a few points. I can pick up a few points, but the methodology by which I'm going to graph is completely ignore the points and go with this part, and this part. I'll show you in a moment. But for example, -1, so you know which piece to use. It says if x is between -1 and 1, including -1, you can use this one. So if I put -1 here, I get +1 and 1 is 2. Zero is in between, so I get +1. 1 is this one, gives me 2. 2, x larger than 1 is here, 2 comma 4, 3 comma 9, 4 comma 16, and so on. So those are the points. These are the pairs. You can use those pairs. Those are fine. But I'm going to look at just the top piece. It's y equals -x plus 1. And I hope you know that the intercepts 0, 1 is just looking at you. And if you set this one equal to 0, x becomes 1, 1, 0. So you locate those two pairs. Okay. 0, 1. This is 2, everybody. So 0, 1, 1, 0. Connect them. This is the line. Now, again, I'm going to do one by one, and I'm not going to look at this restriction. Yes, this one yet basically means the pair 1 comma 2. The point 1 comma 2. This is 1, this is 2, this point. And then the graph of y equals x squared is a parabola. Now I'm going to go back and look at the restriction. This is good from -1 to 1. So when we plug in -1, we get 2. So locate -1 and 2. So this point, -1 and 2. And because of the equality is there. And then plug in 1. If you plug in 1 here, you get 0. But 1, 0 is here, and there's a hole there. So this part, this one, solid point, this one, hole. So this is a portion of a graph. So is this point. Now y equals x squared when x is larger than 1. So if you plug in 1, you get 1. So locate 1, 1, which is here, and that becomes a hole and then everything to the right of it. So this becomes a whole at 1 because equality is here, and then the rest of it. And so this part, whole, whole, this portion of the parabola and this point looks like this. Now, what is the domain? The domain starts from negative 0.1, negative 1. Is negative 1 included? Yes, that's a solid point, and it goes all the way to infinity. Range starts from 0 and goes to infinity, but 0, I don't see any point. I see a hole here. 0 is not included. So domain, negative 1 to infinity, negative 1 is included, the endpoint. Range 0 to infinity, 0 is not included. Find the average rate of change of f of x equals x squared minus 3x from x equals 2 to x equals 4. So the average would be f of b minus f of a over b minus a, or simply f of 4 minus f of 2 over 4 minus 2. That is by definition average rate. So we're going to plug in 4. We get 4 squared minus 3 times 4 minus, we're going to plug in 2, 2 squared minus 3 times 2. And we're going to simplify the numerator. So (16) minus 12, 4 minus 6 is minus 2. That means plus 2. So the numerator is 6. Halves equals 3. Six halves equals 3. So pretty straightforward, everybody. Now find the average rate of change of f of x from x equals 4 to x equals 4 plus h. So simply put, we want f of 4 plus h minus f of 4 over 4 plus h minus 4. In other words, we are looking at this one, everybody. So let's go back to the function and plug in 4 plus h. That means 4 plus h squared minus 3 times 4 plus h. And then 4. You can use f of 4 here. That was evaluated at 16 minus 12, or simply 4, or just use 4 squared minus 3 times 4. Either way is fine. The bottom, of course, 4 and negative 4 cancel each. So let me. So all you have to do is simplify the numerator. A plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. So those are identities that we should know. Therefore, 4 plus h squared is 4 squared, which is 16. And then 2 times 4 times h plus 8h plus h squared minus 12 minus 3h. This is 16 minus 16. This is minus 12 plus 12. I am not simplifying the brackets in because of the following reason. We can easily see this cancels this one. This guy cancels this one. And then 8 and negative 3 add up to 5h. So h squared plus 5h. I can factor the h out, drop the h, you get h plus 5 as the final answer. Find the value of x if a linear function goes through the following points and has the following slope. So the pairs x comma 2 minus 4 comma 6, m is 3. And so let's discuss a little bit about the lines and remind everybody, lines are in the form of standard x plus by equals c, slope intercept form y equals mx plus b, and point slope y minus y1 equals m times x minus x of 1. Vertical line x equals a, m is undefined, x-intercept is a0, horizontal line y equals b, m equals 0, y-intercept is 0, b. Two lines are parallel if they have equal slopes, different y-intercepts, perpendicular if the product of their slopes is -1 or one is the negative reciprocal of the other. I hope everybody remembers all of this, but just in case. Now, m is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or delta y over delta x, or rise over run, or the average rate of change of y with respect to x. So y sub 2 minus y sub 1, that means 6 minus 2, over x sub 2 minus x sub 1 means minus 4 minus x, and it's equal to the slope, that means equals 3. Cross product will do that. We're going to multiply 3 by minus 4 by minus x. And 6 minus 2 obviously is 4, everybody. So this is 4. And I multiply by 1. These two, these two. And we simplify, we get negative 12 minus 3x on the left. Move negative, make it positive 12. Divide by negative 3. X must be negative 16 thirds. Consider this scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. That means it's linear. Find the linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. You can just quickly plug in, you should recognize this is the initial value. So if we go with y equals mx plus b, that is the initial value of b, and 2,500 per year is the average rate of change, that is the slope. So P of t is the population as a function of time, t. The constant rate of growth, which is m equals 2,500 per year. The initial population of 75,000 represents b, the y-intercept. So the linear function would be y equals mx plus b. We are going to change that to p equals mt plus b. So again, we go back to what we know, and then we use new variables. So p becomes a function of t, or p of t. Remember, y is the same as f of x. This is p of t. M 2,500, t plus b is 75,000. What will the population be 10 years from now? Well, or from the beginning. Just replace the t with 10. Obviously, this is 25,000. With 75K becomes 100,000. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes cost $71.50. 720 minutes cost $118. Express the cost C as a linear function of the monthly minutes used X. Again, it's important to write the proper pairs. Normally we use X and C. In this case, we're going to use minutes and cost, X and C. Normally we use X and Y, but this time is X and C because C represents the cost. Now, let's look at the pairs. This one would be 410 minutes, $71.50. This one, 720 minutes, $118. So we have the two pairs. The slope is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But we are going to use c sub 2 minus c sub 1 over x sub 2 minus x sub. Again, I write what we normally use and what we have to use now. So it's 118 minus 7150 over 720 minus 410. 118 minus 71.5 is 46.5. 720 minus 410 is 310. And the ratio is 3 over 20 or 0.15, either in the form of a fraction or decimal, makes no difference. Since we are dealing with money, most likely, ultimately, it's a better practice to go with the decimal. But in any event, now the equation, we want to write the linear function. Y minus y1 equals m times x minus x sub 1. So instead of y minus 1, we're going to have c minus c1. Okay, c minus c1. So you use one of those pairs. For example, c minus 118. So let me just write at top of it, c minus c1. So c minus 118 is m. Use this one or this one, doesn't matter. X minus 720. And you work it out. You multiply these two. 720 is divisible by 20. You end up with 108. Negative. Move this by making it positive. And you get C equals 3 over 20 or 0.15x plus 10. Now, before we move on, I would use, okay, so which pair did we use here? We use this one. I would use this pair to check. So make sure you check before you move on, okay? And it does check. Now, what is the cost when we use 687 minutes? So replace the x with 687. Money, you go with two decimals, $113.05. Interpret the slope and the c-intercept. The c-intercept represents the fixed monthly cost flat fee charged by company, which is $10. So this is a flat fee, meaning doesn't matter, use it, don't use it, they're going to charge $10. The slope represents the change in cost per minute of call for the amount of 15 cents or $0.15 per minute. So you do 1 minute, they charge you 15 cents. 2 minutes, 30 cents. 10 minutes, $1.5. That's the idea behind this slope. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals x minus 1/4 x squared. Include proper units. How tall is the sunflower 8 weeks after planting? Well, f of x is 6x minus 1/4 x squared. That's the height. So after 8 weeks, plug in 8. 10 weeks, plug in 10. So whatever that number is, plug in f of 8. That means 6 times 8 minus 1/4, 8 squared. This is 64. This is 48. 1/4 of 64 is 16. 48 minus 16 is 32. 32 inches. So after 8 weeks, is 32 inches, the sunflower plant. Find the average rate of growth from the end of week 6 to the end of week 12, f of b minus f of a over b minus a, or f of x minus f of a over x minus a. That means basically f of, so rise over run. F of 12 minus f of 6 over 12 minus 6. That's the meaning of it. So 6 times 12 minus 1/4 12 squared minus brackets or parentheses 6 times 6 minus 1/4 6 squared. 72, 12 squared is 144. This is 36. This is 36. This is 36. 1/4 of it is 9. So it is actually easier if you do this. Minus 36 plus 9, this one, this one, this one, add up to 0. So you have 9 over 6. Or so this is 72 minus 36. Let me actually erase and show you. 72 minus 36. 36 minus 9. And it's 9 over 6. Simplifies to 3/2 units of the numerator over the units of the denominator. So units of the height over the units of the time, inches per week. And that's the final answer of it.